So let's go ahead and get started. We'll start off by giving some quick background on the Configuration Assistant, which might be a review for most people who have used it for policy configuration. Then we'll spend most of the presentation on TCP/IP profile. I'll review the basic profile support, talk about how Sysplex and Reusable configuration work, and we'll start talking about new functions, including system symbols, profile import, and the newest function, dynamic reconfiguration, which I know the APAR has closed. I don't know if the PTFs are available yet because we just closed the APAR a week or two ago. So starting off with the background of what is the Configuration Assistant, hopefully this is review for most people because most of our customers are already using the Configuration Assistant to configure your policy-based networking. The Configuration Assistant is a GUI tool. It's a plugin to OSMF, and it has supported for years configuring our policy-based networking technologies, which consist of IP security, ATTLS, intrusion detection, policy-based routing, and quality of service. Those capabilities have been around for years, and a lot of people have been using them. It's a GUI that creates a policy files that the policy agent daemon runs, and then installs the policies into the stack. As you can see from the diagram on the right, the policy infrastructure is quite complex, and the Configuration Assistant makes it a little bit more accessible and easier to use. We've been doing this for several years, but starting in V2R2, we've added TCP/IP profile to the Configuration Assistant. And TCP/IP profile is the focus of this presentation. So the Configuration Assistant is a OSMF plugin. It's under the configuration line on the navigation map on the left when you go into OSMF. And you open that and open the Configuration Assistant, and it opens, and you get this opening screen. And here you can choose many things. You can manage ZOS Cloud configuration, which is outside the scope of this presentation, or you can manage TCP/IP profile and policy-based networking functions, which is this presentation. You can create a new backing store or open a backing store. A backing store is basically the file that the Configuration Assistant uses to store its data in. It is not a TCP/IP profile. It's a Configuration Assistant file that it uses to store things in its own format. But it's from that we will eventually generate TCP/IP profile files. So the Configuration Assistant supports multiple technologies, as I said, and this screenshot shows you where you choose the technology. Once you open up a backing store, at the top you select which technology we're going to configure. These used to be called perspectives, and all of the areas that it supports are there. They're all in the same backing store. So in the backing store you can have TCP/IP profile and IPsec and IDS. Or you might choose to manage it differently and have a different file for each one. However, in one file it's a little bit more efficient because you can share resources between the technologies. What we're interested in here is TCP/IP profile, so we're going to select that one. And then we have, once you've selected your technology and gotten in the backing store, you have the systems tree. The systems tree is something that's not new for TCP/IP. It's existed before in the policy-based profiles, but it basically gives you the layout of your system. You define, at an upper level, you define a group, and a group is a Sysplex. The default group is all the stacks that are not in a Sysplex. And within a Sysplex, you define system images, which would be the LPARs, and then within the LPARs, you define the stacks. This tree is shared by all the technologies. So if you were to pull down the technology and change it from TCP/IP profile to IPsec or something else, you would still see this tree. And to configure a stack or a Sysplex or an image, you select it and pull down Actions Configure. What you get when you pull down Actions Configure varies depending upon the technology you're configuring. I mean, TCP/IP profile configuration is different from ATTLS configuration, which is different from quality of service configuration. So in the systems tree, this is where you build your system. In this example here, I've selected LPAR2, and I selected it because it didn't fall under the drop-down when I clicked on Actions. You click on Actions, and I've shown here there are some actions you can do. You can create a new Sysplex, also known as a ZOS group. You can create a new ZOS image in the Sysplex that LPAR2 belongs to, or you can create a new stack on LPAR2. And here you're creating the representations of them in the Configuration Assistant. So in this example here, on the next slide for the systems tree, the user has selected stack 1 on LPAR1. You can see it selected. There's two ways you can access functions for that. One way is you can pull down the Actions menu, or in this example, you can also right-click on a stack to take specific actions. And when you right-click on an element in this table, the action specific to that will pop up. So we'll discuss other actions later, but here, if you click on Configure, which is, I think, the fourth one down, you can edit the stack's configuration. This logic works in all the technologies. So in TCP/IP technology, you click on a stack and you click Configure, you're going to be editing the TCP/IP profile. An IPsec technology, you would be editing the stack's filter rules and so on. So the next question is, where do you get help? The Configuration Assistant has extensive help, which we will freely admit always needs improvement because we write the help and we understand it well, so we're always looking for feedback on what can be more helpful in the help. But in almost every screen in the upper right-hand corner, there's a small help link, which if you click on the help link, it takes you to a knowledge center, and the knowledge center brings up the topic for the screen that you were on when you clicked the help link. But on the left, there's a table of contents where you can explore. You don't have to just look at the Knowledge Center write-up for this particular panel. You can access a table of contents, and here there's just a blow-up of what the table of contents looks like, where at a higher level it shows all the OSMF help. This is a OSMF Knowledge Center, not just a Configuration Assistant. There's a section for the Configuration Assistant task, and then under that section there's a twisty for tutorials. If you open up the tutorials, you see a list of tutorials that can be accessed, and we have quite a few tutorials. Tutorials on each technology on getting started, tutorials on getting started with TCP/IP, and then we have additional TCP/IP tutorials which give basic information like, how do I find and configure resources, how do I configure global properties, how do I import a profile, how do I configure interfaces, how do I configure routes. So there's a lot of tutorial information there that I'd strongly encourage you to check out if you're new to this. And we'd also encourage feedback on those tutorials on how useful they are or are not, or how they could improve. So starting in V2R2, we now configure the TCP/IP profile. It was simply added as a technology alongside the policy-based technologies, and it allows you to configure and manage your TCP/IP profile. So what I'm going to do here is I'm not going to step through everything, but I'm going to give some basics on how we do TCP/IP profile, and as we go through more pieces of it, we'll see more screens. So in the TCP/IP profile, you see here I'm in my system tree. I've selected LPAR1 stack 1. I right-clicked on it, and when I click on Configure, that allows me to configure a TCP/IP profile. And you can configure the complete TCP/IP profile. Everything in the TCP/IP profile is here. And to make it more user-friendly, we've tried to group them into logical task areas. So when you click Configure, you get this next screen, which basically lays out the basic tasks in order, right? First you define interfaces, then you define routes, then you reserve ports, then you do your security, then you do source IP addressing, then you tune, then you do management and stack. And if you're using the cloud technology that's outside the scope of this, you can also configure cloud datasets. Now in this path, I've selected a stack, and I'm configuring the stack, so we're going to talk about stack-specific resources. I'll talk a minute later about how we do Sysplex resources, which are at a higher level. So we're going to do an example here, just a real quick one. I'm going to go through configuring an interface. So you click on the link for interfaces attached to networks, and it takes you to the next slide. The next slide gives you a table, and it's a table of defined interfaces. And I'm going to add a new interface, so you can click and pull down Actions New, which will then take you to the panel on the next slide. And you get a wizard. You get into a wizard for defining a TCP/IP interface. And in this wizard, first you have to name the interface. Then you have to tell us what type of interface is it. In this case, it's an Ethernet LAN, OSA chip OSD. And you also have to select the address family, which we're going to do an IPv4 interface. Then you click on Next. You define the connectivity. That's where you define the IP address, the subnet mask, the port name. If there's any VLANs to identify, you do the VLAN. If you're using source IP addressing, you can pick the source IP address here. The source IP interface here, the source VIPA. Then you do the connectivity, then you click Next, and you get to a screen of additional properties. And the screen of additional properties has, do I start this interface right away? And then there's an Advanced Settings tab that we won't go into here for time, but in Advanced Settings you set just basically everything else, QDI storage, queue limits, queuing, that type of stuff. You click Finish, and now we've created an interface, and we go back to the table, and you see that there's now an OSA 11 that's in the table. And OSA 11 is defined as an OSD interface with the IP address. And then the status sheets have a green check, which indicates the definition is complete. So this interface doesn't have anything stopping it from being installed. Now you do this for all the configuration. I just did a quick example with an interface, but this is, you define routes, ports, everything in a similar way until you have your TCP/IP profile configured. And then the next thing you need to do is you need to install the configuration. So for the Configuration Assistant, installing means generating the TCP/IP profile and putting it into place. And OSMF has got pretty good capabilities, or the CA does, for where you can put it. You can save the profile to a data set on the same system where OSMF is running, or you can FTP it to another system or another image. So when I go back to my systems tree, and I have you can see here I've selected stack 1 out of LPAR 1 that's in Plex 1, clicked Actions and pulled down and selected Install Configuration Files. When you do install configuration files, it takes you to a screen that lists the configuration files to install, which in this case is the TCP/IP profile for stack 1. I can right-click on that or pull down Actions and click on Install again, and here's the screen where I tell the Configuration Assistant where to put the configuration. You specify the file name. We provide the default file name, which is your user ID .tcp/parms and the stack name, but you can change that. And you can either save to disk, which is what you would do if TCP/IP is running on the same image as the OSMF, or you can FTP it to another host, and then you have to provide the FTP information. Then when you click Go, we will put the TCP/IP profile in place. Now, I'm sure everybody on this call already has TCP/IP profiles that were edited and created in green screens, and they're not going to just stick something out there without having a chance to preview it. So on the next slide, you can also look at the configuration that Configuration Assistant generates. This is back in the install screen. When you click on the stack, you can either show the configuration file or install it. When I show the configuration file, we show you the contents of what's going to be installed. In this example here, this is the TCP/IP profile for stack 1 that will be installed by the Configuration Assistant, so you can review it before sending it over. And I've highlighted in red OSA 11 because that's the interface we created a few slides ago. So that's basically the task you go through to configure. If you go to conferences like Share or ZTechU, we usually have a lab where you can play with this and spend more time with it on one of our systems, or you can play with it on one of your test systems. But one of the biggest questions we get is, okay, I know where to configure a certain parameter, say like IQDO queuing or something like that. Where do I find it on your panels? Well, if you go to our Help again, and you go to the Knowledge Center, you can click Help on any screen to get to this Knowledge Center. You scroll down to Tutorials, then you scroll down to TCP/IP Additional Tutorials. And TCP/IP Additional Tutorials, the first one is How do I find and configure resources? Page 2 of that tutorial is a table of all the resources and where to find them. So this is an easy place to go if you want to find out, for example, where do I configure auto IQDX? Where do I configure ECSA limit? This will tell you where to find the panels for each of those parameters. So that's a handy thing that a lot of people end up using, especially people that are already familiar with TCP/IP profile and they want to know they need to change a parameter, they know what the parameter is, they don't know exactly what panel it's on. This will help you get there. Alright, so we talked a little bit about the TCP/IP profile for stack-specific stuff. One of the things that's very powerful about the Configuration Assistant is we make Sysplex management easier. As anybody who has a Sysplex knows, and you have distribution and you have application instance to VIPAs, you know that a lot of coordinated definition is required. Right? You have to define a VIPA define on the primary host, you have to find VIPA backups on the host that will back it up, and those definitions have to be coordinated, and this is error prone. Or for just about any Sysplex parameter, they're almost always global to the Sysplex, but have to be defined individually on the stacks. So in the Configuration Assistant, we've made this easier by providing what we call a single system Sysplex representation. If you look at the picture here on the left, I have my system tree again, but I've highlighted the Sysplex instead of a stack, and there's a configure Sysplex networking function where you configure Sysplex information for the whole Sysplex. When you configure Sysplex networking information, you end up with a screen that's similar to TCP/IP, but it's Sysplex networking. Here's where you define dynamic XCF, monitoring, application instance to VIPA ranges, VIPA distribute, and VIPA route. And you define it for the whole Sysplex, and then the Configuration Assistant automatically generates the correct information and pushes it to each stack. So therefore, that relieves you of the need to coordinate definitions in flat files. The Configuration Assistant does it for you. And now we're going to do an example of one. I'm going to show you how we define a dynamic XCF network. So here is the Sysplex networking screen, and Sysplex network attachment is dynamic XCF. So the way this works is you work it in two steps. First, you define what's the dynamic XCF subnet for the Sysplex using these panels, and then you attach individual stacks to dynamic XCF. So if I click on Sysplex network attachment, I get a table where I define, and in this example it's already been done. For IPv4, the subnet address for dynamic XCF is 1.1.1.0 with a 24-bit prefix length. For IPv6, the subnet prefix for dynamic XCF is 2001 dog baker 8 1:1 with a 64-bit length. So that defines the dynamic XCF subnet for the whole Sysplex. And then down below you see a step 2 with a link to attaching stacks to the dynamic XCF network. You click on that link, And then for each stack, it shows you all the stacks in the Sysplex. You can either right-click on a stack or pull down Actions and click Attach, and it gives you a screen to attach this stack to Dynamic XCF. Now, one thing about this panel is it reminds you what the subnet and prefix is of Dynamic XCF. If you try to attach this to Dynamic XCF with an address outside that subnet, we will let you, but we will warn you. Right? It's not a best practice to attach outside of a subnet, but we found that some customers do it, so we've had to permit it, but we warn you. So it's an attempt to try to encourage best practices. So you would put in the IPv4 address for the Dynamic XCF address for this stack, change its cost network if necessary, set a source VIPA if you want, and if you want to do IP filter rules and traffic descriptors, you can give it a traffic descriptor. You can also indicate whether or not it's eligible to use SMC Direct, which was a new function added in V2R2, and then you click OK, and you've created the Sysplex, the Dynamic XCF definitions for this stack. There are similar steps for IPv6. So once you have gone in the panels and attached all the stacks to the Sysplex, Configuration Assistant then pushes the correct Dynamic XCF statement to each stack without you having to do coordinated definitions. And other Sysplex resources like distributed dynamic VIPAs, VIPA range, and VIPA route work similarly. You define them centrally in one place under the Sysplex panel, and the Configuration Assistant pushes the correct definitions to the stack, saving you all that coordination, which hopefully also is less error prone because you don't have to worry about miscoordination. So here's an example of a generated configuration for a stack, and you can see the Dynamic XCF definitions I created are in here because it was pushed to it by the Sysplex definition. You didn't have to define them individually. Okay, so that's how we do Sysplex. Like I said, single system, less error prone, hopefully easier to use. The next concept I'm going to talk about is reusable configuration. Most of our customers have include files in their TCP/IP profiles. They don't have a single flat file. And include files are generally used to do common configuration across stacks. And examples of include file use cases include port and autolog statements, maybe common interface definitions, maybe common configuration options. So we support this function in Configuration Assistant using objects known as reusable configuration. So I'm going to talk a little about reusable configuration and how that works, which is the analogy to how you would do include files. A reusable configuration object is a set of configuration that will be used by multiple TCP/IP stacks in the Configuration Assistant. Reusable configurations have their own tabs on the system tree. So if you're on this TCP/IP system tree, you can see there's a tab for reusable configuration. You can also see a tab for change sets, which I'll talk about later. If you click on the reusable configuration tab, you get a table of reusable configurations, and you can pull down Actions New. In this example here, I've created a new reusable configuration, and this is a common port definition. This is a very common use case where customers will have their port definitions in an include file that gets included in multiple stacks. Here we're going to create a reusable configuration for ports. So I've named it, and I named it ports. And then you tell me which TCP/IP stacks are going to use this reusable configuration. So in the next slide, when you create a reusable configuration, you get the Select Systems window, and it shows you all of the stacks and systems that you have in this backing store. And you just check the ones that are going to share this configuration. In this example, everybody in Plex 1 will use these ports. I can check and uncheck a whole Sysplex, and I can check and uncheck individual stacks. But that's choosing these are the ones that this configuration is going to be pushed to. Once the configuration is selected, then we're prompted to configure it. So I click Finish, and it says, do you want to configure TCP/IP resources for reusable configuration? Which is basically, now it's time to create the common configuration. So you can click on Proceed, and you get a configuration screen that looks very much like the TCP/IP configuration screen, because you can put just about anything into an include file in TCP/IP, and we support that with reusable configuration. The difference is that the configuration you create here isn't specific to a stack, it's reusable, and it's going to be pushed to all the stacks that we said use it. And it works the same way with some small exceptions. So in this case, we're configuring common ports, so I click on the link for ports, and it takes me to the next slide, and I have a port definition panel, which looks just like the port definition panel in a TCP/IP profile, except we're going to be doing it common. So I have a table of ports, and I can click on Actions, New, Reserve a port or a range, and I'm going to create a port reservation for the standard telnet port. So here I create a reservation, I describe it, I put in a description, standard telnet port, it's port 23, it's TCP, and it's reserved for job name telnet. Right? When I click OK, I go to the next slide where it's created, and you can see now my port table has port 23 is reserved for Telnet for the standard port. Everything else is unreserved, right? Ports 1 to 22 are available. All the ports above 23 are available. All the UDP ports are available, but I've created a reservation for the standard Telnet port. Now, like I said, this is a common configuration that's going to be shared to multiple stacks. So my next step is to push it to multiple stacks. So here I am in the Reusable Configuration tab, and you can see that my ports Reusable Configuration is the first one. It has an install status of never installed. What we have to do is we have to install it in the stacks. This is what pushes it to the stacks. And the action for that is promote to installed. When you do promote to installed, two things happen. First thing we do is we validate the reusable configuration. For example, the reusable configuration can't conflict with the stack you're pushing it to. You can't create duplicate names. You can't create conflicts with what's in the stack. So we validate that. If it fails that validation, you're sent to a screen where you can see where the errors are and get a chance to correct them. Now, ports isn't likely to happen, but if you define a port definition that was exactly like one that was already in one of the base stacks, that would be a conflict and we wouldn't permit it. Or if you're defining an interface, you can't define one with the same name and reusable configuration that exists in one of the stacks that's being pushed. So there's things like that we verify to make sure that when you push it to the stacks, you're not going to create conflicts. This is additional error checking that you don't get when you're using flat files with include files, right? When using flat files with include files, they just get included and you get the errors that you get. If the validation is successful, then the configuration is pushed from the RC to all the stacks. So I click on Promote to Install. It says you've promoted all the stacks successfully, which means that configuration is now in the stacks that were checked on the previous screen. Now, reusable configuration is meant to be edited in reusable configuration. By that I mean, just like when you're doing flat file TCP/IP configuration, you can't go into the main profile and edit the contents of your includes, right? You have to edit the include files. Same thing here. Configuration that is defined in a reusable configuration is managed and configured through the reusable configuration interface. You can't go to one of the stacks and edit it. You have to edit the reusable configuration and reinstall. So the next slide shows you what I mean. Here is, on the left-hand side, is a backing store. These are the reusable configurations. The port configuration I just pushed, you see it's installed. And on the right-hand side, I've gone into stack 1 of Plex 1, and I've gone to its ports configuration, and you can see in the ports table there's a column for origin reusable configuration. If this configuration, if a port was defined locally to this stack only, that column would be blank. But in this case, port 23 was defined in a reusable configuration, so it tells you it came from reusable configuration ports. You cannot edit it here in the stack. You have to go to that reusable configuration to modify it and then push it back to the stack. That's how we manage common configuration. Now, even though we're doing reusable configuration in multiple files, we do not generate include files. The Configuration Assistant, the paradigm of the Configuration Assistant is that you manage things in the Configuration Assistant and just push the results. So reusable configurations that are pushed to a stack are simply included in the file that we generate for that stack. We don't create an include statement. We just generate a flat file with the reusable configuration. They are not reusable configurations, not maintained as separate files, because we're trying to move, and we know it's a journey. We know people aren't going to get there right away. We're trying to move to a paradigm where people use the Configuration Assistant to manage their profiles, not the green screens. Now, I'm not saying we're ever going to take away the green screens, because we're not, but our goal is for you to use the Configuration Assistant to do this management. So what I've talked about so far is function that was shipped in COM Server V2R2. The rest of the functions we're going to talk about have been shipped in SPEs going forward. So the first thing I talk about is system symbols. System symbols, I'm sure customers are familiar with them. Customers often use MVS system symbols along with include files to manage common configuration. Common use cases for system symbols generally include location-specific information like interface name or IP address that's in a common file, or names like that. Configuration Assistant does implement its own version of system symbols. We shipped APAR PI 66143 in September of last year that added support for Configuration Assistant system symbols. They're similar to MVS system symbols. They use the same syntax, ampersand, symbol name, dot. It's important to understand that Configuration Assistant does not access the IEA sim table. It does not access MVS system symbols. Configuration Assistant system symbols are independent. However, when you import TCP/IP configuration, which I'll cover in later slides, MVS system symbols are converted to Configuration Assistant system symbols. So Configuration Assistant symbols are created and resolved within the Configuration Assistant, and they're used within the Configuration Assistant. We don't push configuration with symbols in it. We resolve the symbols. You define system symbols in reusable configuration, which I'll show you in a minute, and then you give the symbols values for each stack that uses the reusable configuration, and then we generate the TCP/IP profile with the symbols resolved. You have to resolve all the symbols in CA before you can install a stack. Let's go through some more information about it. These are the fields where we support system symbols. It's not like in TCP/IP where you can just put a symbol anywhere because we have to process each field. We went and got feedback from customers about what fields they need symbols in, and this is what we got back. And I will let you know if there are other fields you need symbols in, let us know either by sending me an email or opening an RFE. So the interface name can be or contain a symbol. The interface IP address can be or contain a symbol. Ignore that rule for now, I'll talk about it later. Interface TRLE port name, interface VLAN identifier, SRC IP address, they can all be or contain symbols. We have also received feedback, and when I say interface name and interface IP address, I'm talking about anywhere an interface name or interface IP address is referenced. So for example, in a static route, the outgoing interface name can have a symbol in it. We have gotten some feedback requesting the next hop for a static route also have symbol support, so that is on our to-do list. But if there are other fields where you feel that symbols are needed to manage your configuration, please let me know, because these symbols were based on customer feedback and we're always taking customer feedback. So the way a configuration assistant system symbol is defined is when you're in a reusable configuration, it's like Rex. If you're an old programmer that remembers Rex, to define a symbol, simply use it. So in this example here, I'm creating a reusable configuration for OSAs, and I've created a file, I've created a host, and I've created an interface, and I've named it OSA & host dot. That & host dot is a CA system symbol as soon as you click next on this screen, and we automatically create them and track them. And as long as you enter it into a supported field in a reusable configuration, CA sees it and creates it into its symbol table. Now, for interfaces defined in a reusable configuration, we do require you to use a symbol in the IP address, which makes sense because a reusable configuration is supposed to be used in multiple stacks. You obviously can't use the same IP address in multiple stacks. So there's two choices. You can see here on the screenshot that you can either let Configuration Assistant generate a default symbol. In that case, it'll be &interface name _ IP adder, or you can provide an IP address. And the IP address can be a system symbol. For example, it could be simply &adder, or it can contain a system symbol. For example, in this case, I've said, okay, the IP address is going to be 1.1.1. &host dot. So there's a symbol in that so that I can vary the IP address across stacks. You also notice down in the port name field, I've also used the symbol there. So the port for it is going to be port &host. So I'm setting up a system where for each stack there's a symbol &host has a different value, factors into the interface name, the interface IP address, and the TRLE port name. Now when you define symbols, you have to resolve them. They eventually have to have values. And there's two avenues for resolving symbols. You can do it through the reusable configuration or through the stack. And here this shows you how to do it through the reusable configuration. You can't see it because the drop-down covered it, but I've selected the OSA's reusable configuration, and there is a menu item for RC symbols, which stands for reusable configuration symbols. And when you do that, it shows you these are the symbols defined in this reusable configuration. In this case, there are two symbols defined, sim1 and host. And then I can right-click on a symbol, or I can pull down actions, and I can select modify. And it's through that interface that you set the value of the symbol. So in this case here, I'm saying for symbol host, it shows me for the three stacks that this reusable configuration is included in, these are the values of the symbol in each stack. So for example, in stack 1, the value of host is 1. In stack 2, the value of host is 2. In stack 3, the value of host is 3. And from here, I can modify the value. I can right-click on it and select modify, or I can pull down actions modify, and it gives me a screen to put in a new value. And this way, this is one way to get easy access to all the symbols that are defined in a reusable configuration. You can also do it, and I'll show you in a minute, from a stack point of view where you can set the symbols by stack. But this is how to do it through reusable configurations. This is all the places &host is defined. You can see and change the values. Now, one of the things that the Configuration Assistant does that is helpful is we do error checking for you. So when you set a value for a stack symbol, the Configuration Assistant verifies the value won't cause any errors. This cuts down on configuration errors. For example, in this case, I attempted to set &host to 999. You might recall that one of the uses of &host was the last octet of an IP address. 999 is not allowed. So when you try to set the value 999, you get an error message that says, hey, that's an invalid value for at least one user of this symbol. And if you click OK, we'll show you every place the symbol is used so you can debug the error. If you click cancel, you go back to the screen to set a new value. So this way you cannot set a symbol value that will cause errors later, which is definitely an improvement over doing it through IEA Sim, where you can set symbol values and we don't find out they're going to cause an error until the TCP/IP stack reads the profile. Now, I showed you how to resolve symbols via a reusable configuration. You can also do it from a stack point of view. So here, I'm at the systems tree. I've selected stack 1 in Plex 1, that's an LPAR 1, and you can see there's an action stack symbols I can do, which takes you to the next slide where you can set the symbol values for the stack. And here's an example of the stack symbols for LPAR 1, stack 1. These are the symbols that are included in this stack, and you can see the 2 from the reusable configuration OSs are here. And you can also see other symbols are here. There's an internal Sysplex symbol. And if this stack had multiple reusable configurations pushed into it, you'd see all their symbols too. So this is a view via the stack. So I can modify the value of host just like I can through reusable configuration. I can change its value here. I get the same error check that I showed you on the last one. You cannot set host to hello or 999 or anything that would cause a syntax error when the symbol is resolved. Now it's important to understand, I mentioned before, you have to give all the symbols a value. When Configuration Assistant generates configuration, it generates it with symbols resolved. So here's an example of an interface table where I've got VIPA1, whose address is 4.4.4.ampersand host, which has been resolved to 1 on this system. And VIPA7 is 1.11.7.5, or ampersand sim1, which is equal to 5. When we generate the configuration, the symbols are resolved. So the generated flat configuration is flat values because we expect the symbols to be managed through the Configuration Assistant. All right, the next topic I'm going to hit is TCP/IP profile import. I'm sure it's of interest to everybody because most of our customers already have working TCP/IP profiles, and most customers are not interested in going through a whole bunch of menus and recreating their configuration from scratch. That would be tedious and error-prone. So in September of last year, in APAR PI 66143, which is the same APAR that shipped the symbol support, we shipped TCP/IP profile import. But it's important to know that it requires a companion APAR from Communications Server. It requires PI 63449 from Configuration Server. Because there's 3 steps to import. The first thing you have to do is run a vary command on the ZOS Communications Server, and that will output the TCP/IP configuration in a form that's readable by Configuration Assistant. And then you take the file that was created in that step and import it into the Configuration Assistant. And then 3, you fix the errors, because there will be errors. So the first step of importing your profile is to export it from TCP/IP. There's a new vary TCP/IP command, export profile. You run it against the ZOS Communication Server and you specify the MVS dataset that is the root of the configuration to be exported. Com server will read the file and all of its includes and create a file in /var/exportprof for the Configuration Assistant to read. What you're basically doing here is you're exporting your profile as a JSON file. Now it's important to understand because this is different from how it works in the policy side. We read and export the specified profile. We do not export our running configuration. Right? So we read the profile, we run it through the syntax checker, and then we output JSON. What this means is that you can export any profile from a TCP/IP stack. It doesn't have to be the one that's running, with limits, which I'll talk about in a minute. So when you do this export, the stack detects syntax errors in the profile, and it won't let you export a profile with syntax errors. However, it does not detect context errors. All it does is check the syntax. For example, if you have 2 IP interfaces with the same IP address, that won't get caught by exportprof. We'll export that profile. The stack will also export the values of all MVS system symbols used in the profile so they can be converted to CA symbols with the values resolved. Now there is one important rule here. I said you can, since it reads the file, you can run exportprof to export any configuration, but if the profile to be exported contains MVS system symbols, you have to run it on the same MVS image to make sure we export the correct symbol values. So the next slide shows an example of doing an exportprof command. You can see I do a vary TCP/IP exportprof. User.tcp/IP params TCP/IP. You see it opens up the file, it opens up the include files, it reads the include files, it exports it into a file, and if you look down, the third line from the bottom shows you the name of the file that we exported to, var exportprof mvs1.tcp/IP1.timestamp. And that's the file that's created. That's the file that you then read into the Configuration Assistant. After you've exported the file and it's sitting there in the exportprof directory, you can then go get it from the Configuration Assistant. So first thing you have to do is you have to have a stack created to receive the configuration. So you need to create a stack. Don't do any configuration. You can attach it to the Sysplex with dynamic XCF, but it can't do any other configuration. A stack that's going to receive an exported file has to be empty. All right. You can select a stack and pull down Actions, Manage, Import of Formatted Configuration Data, as shown here. And that takes you to a wizard where on the first screen you tell the Configuration Assistant where is the file to import. And this is where you put in the var export prof name. And you also tell me where to get it. You can retrieve it from the disk if it was exported from the same image that we're running on. Otherwise, you can FTP it from another host. In this case, it's being FTP'd from another host, so it's saying go get that exported file and import it. On the next screen, we read the file in, and the Configuration Assistant maintains your original include structure. So in this case, there were two include files named ports and interfaces. So in this screen, we ask you, how do you want to import these things? Which file is the base and which ones are the imports? Because we don't necessarily know which file is the base configuration. Some customers put their base configuration in a big include file and then have specific stuff in the root file. So here we give you an opportunity to select which one's the base. There can be one base. Every other file needs to be reusable. And those reusable files, you have to give them names. Reusable configuration name. So in this case, I'm saying user.tcp/params.tcp is the base configuration. User TCP params ports is a reusable configuration named ports, and user TCP params interfaces is a reusable configuration named interfaces. When you click next, that's when we actually import the data. Now, you're not done yet because there are likely post-import actions. I'm sure everybody knows how sophisticated and variable TCP profile is. So the Configuration Assistant might not be able to completely resolve an import file. Configuration Assistant encourages best practices but doesn't require them. But Configuration Assistant also does stricter error checking than you probably do. So you might have errors in your TCP configuration that you're ignoring that the Configuration Assistant doesn't ignore. You can't install a file with errors. You also might import profiles in an order that doesn't resolve everything, especially in a Sysplex. Right? Because, for example, if you import the file that has the VIPA backup before you import the file that has the VIPA define, that could be an unresolved reference. If you import a stack that has a VIPA route statement that references a stack that hasn't been imported yet, that will be an unresolved reference until you import the next stack. So after you're done with the import, you get an import report on the last panel of the wizard that tells you what you have to do to finish. Now I'll also point out from a philosophical point of view, we said import should not be something you do routinely. It should be like a 1 or 2 time thing. So it was okay to leave some work for you to get it right. Otherwise, we'd still be working on it to resolve everything. So here's an example of an import report for an import, and you can see that there are 5 errors, 4 of them you can see here on the screen. The first one is a warning. And it says, hey, this dynamic XCF address is not in the same subnet as the Sysplex. The recommended action is to verify that that's the address you want. Right? That's simply a warning. The next one is saying there's no stack that has a VIPA matching the VIPA address as a VIPA route target. So in other words, I imported a stack. It has a VIPA route statement, but the VIPA that I'm using as the target doesn't exist. The next 3 errors are all that, and those are probably because you haven't imported those stacks yet that have that VIPA. As you import more stacks in the Sysplex, those errors will clear up on their own. But there may be some errors that you wouldn't be able to clear up and have to manually fix. And the way you find the things you have to fix, so like I said, export profile can't catch context errors, it can only catch syntax errors. So you might have some configuration imported that's incorrect. Here's an example. In this example here, there were 3 interfaces that had the same IP address. Configuration Assistant doesn't allow that, so it shows you an error. It says, hey, I'm using the same address as these 3. You need to fix these. The way that you find things to fix is you look for incomplete resources, things that are marked as incomplete, and they'll have these error messages here showing you what you have to do. So how do we import MVS system symbols? Like I said, we import symbols, but we don't sync with the stack. So when we import the symbols, if the importer profile uses MVS system symbols in the fields where they're supported, we will convert them to Configuration Assistant symbols. So remember, though, that Configuration Assistant symbols are only supported in reusable configuration. MVS system symbols that we find in the base file will just be imported as constants, regardless of the field. Also, symbols in fields we don't support will be imported as constants. But for the symbols we find in fields we do support in reusable configuration, we insert them into their fields and we populate the symbol table with the imported values. So you don't have to re-resolve the symbols. They come in with the symbols that they had on your MVS system. That does result in some ambiguity. I won't go into the nitty-gritty details, but because of the way export profile and MVS system symbol resolution works, Configuration Assistant, we get the configuration with all the symbol values resolved, Then we do a reverse lookup to restore symbol usage in supported fields. This can result in symbol ambiguity. For example, if symbol ampersand host equals 10, then every 10 we find in a field that supports symbols could be replaced with ampersand host, but that may not be what you want. So if symbol ambiguity exists, we ask you to resolve it. And what we do is we provide you all the possible representations and you choose the correct one. So in the next slide, for example, when I do an import, I get a message on my import report that says I have to resolve symbol ambiguity, and it tells you have to go resolve symbol ambiguity. The way you do that is you go into Reusable configurations and you look for resources that are marked as incomplete as shown on the right, and you edit those resources. And when you edit that resource, you get this screen that shows you select the right representation for this field. In this example, there are two symbols that have the same value. GSK-vol equals MVS220, and so does sysr1 are both equal to MVS220. And we're asking you, which one did you mean? Did you want this interface name to be a constant? Did you want it to use the symbol GSK-vol, or did you want it to use the symbol sysr1? And all you have to do is delete the incorrect ones and leave the correct one, and that resolves the symbol ambiguity for this field. And we always offer you a constant as a possibility. So that's symbols. The next major topic is change set, which is how you do variable files. Change set is something I want to spend some time on because that's a new function we're shipping now. You see the APAR PTF number on this slide. I don't know if the PTF is available yet. We just shipped it, I think it was a couple weeks ago. I'm not sure if it's hit the field yet, but it's on the way. If it's not available yet, it's grinding through the process. Another requirement that we were told we wouldn't be complete until you could do variobey. Right? Variobey is a very important capability configuration of a communications server because it allows you to change configuration without restarting the stack. And we have added variobey support to Configuration Assistant by introducing a new configuration object which we call a change set. And the way a change set works is you create a change set based on an existing configuration object. You can create a change set based on a stack, based on a reusable configuration, or a Sysplex. And what we do is the change set is seeded with the configuration of the object it's based on, and you simply edit it in the GUI. So you don't worry about syntax or anything. You just go in the change set, you make whatever changes you want, and then the Configuration Assistant automatically generates the obey files required to implement the changes you made in the GUI. So it's pretty neat. We create the obey files and you install them like profiles, and they're manually applied by the operator. This is important. Configuration Assistant does not apply the files. We don't go and use any interfaces to run them. We got strong feedback from customers that every obey file gets reviewed by multiple people and we are not to install it. So we put it on the file and then you guys can do the review you need and then the operator can apply the obey file using the variobey command. If there's feedback otherwise, we'd like to hear the feedback we've gotten so far is that customers don't want the GUI to run the variobey command. So in the change set, you can undo a change set, which means if you create a change set and you create the obey files, you can also click undo and we will create the obey files necessary to put it back the way it was. This supports two use cases. The use case we like to talk about is making a temporary change that can easily be removed. The use case that we don't like to talk about is, oops, my change was wrong, I got to get it off. Right? We can do that quickly. You can also merge change sets into the base. So for example, a lot of customers, they do an obey file, they want to make a configuration change, they put in an obey file, they apply the obey file, and then they update the profile, so next time they IPL, they get that. This is a use case. For example, if you're writing a port reservation for a new application, you'll probably do a variobey to add the port statement. You'll probably update your TCP profile to include that new port statement, so next time you IPL, you have it. The Configuration Assistant manages that as well. And I'm going to go over the details of how all that stuff works in the next 40 or so slides. So change sets are accessible from the TCP systems tree. If you look at the systems tree, there's a tab for change sets. When you go to change sets, you get a list of change sets that's similar to the reusable configuration list where you can create a new change set. In this case, I'm starting fresh, so I'm going to create a new change set. Before I show you the panels, let me show you a little bit of animation about a high level how change sets work so we all understand. Here's an example, a conceptual view of the Configuration Assistant where I have an existing configuration, 3 images, 3 stacks. I want to make a change to 2 of those stacks. I create a change set, which is a separate object based on stack 1 and stack 2. The Configuration Assistant copies the existing configuration into the change set. You edit the configuration in the change set. So you go in the change set and you edit stack 1, you edit stack 2, and you edit the changes that you want. That's what the user changes are. And then when you install it, Configuration Assistant generates the obey files necessary to put the changes into effect using FTP or direct save, and then your operator runs the variobey command to apply those change sets. Like I said, that was the feedback we got. That's how customers wanted to do it. They didn't want us doing it without them having a chance to review the files. So now I'm going to show you, we create a stack change set. So here's the new change set. I've pulled down actions new on the change set screen. I'm creating a change set. I've named it CS1, and I've given a description, and I've clicked the radio button to indicate it's a change set for stacks. On the next screen, you name it. You name the change set. The change set has a name. You indicate that it's a change set for stacks. And then you get a screen where you say, which stacks are you changing? And you'll notice here you can change multiple stacks, but you can't change all the stacks. You notice that LPAR3 to stack 3 is not available. It's grayed out. The rule is a stack change set can be based on one or more stacks, but it can only be based on stacks that are installed. In other words, LPAR3.stack3 has been edited, but the changes have not been installed, so you can't do a change set on that. You can only do a change set on a stack that's been installed to the system, where the configuration of the change set matches the TCP IP profile that's been pushed to the system. And I'll explain why that's the case in a minute. After you've picked your stacks, you go to the next slide, and you basically have a change set. Here it is. CS1's been created, and I can pull down Actions, and then I can click Configure Change Set, and then it shows me, here's your change set. It's got two stacks in it. Which stack do you want to edit first? So I right-click on one of the stacks. I do Configure Changes for Stack, and it takes me to a screen that looks very much like the stack configuration screen. The main exception is that there's an extra column telling you whether or not this has been updated. So in this example, we're going to change a tuning parameter. So I click on Performance and Protocol, and I get the tuning screen. And like I said, as you can see, it looks just like the TCP profile, except there's a change set status column where it tells you if anything's been updated. Since this is new, nothing's been updated. So I'm going to change TCP protocol settings. So I click on that, and I get to the next slide. And I just get the screen that looks just like the screen you would get when you were configuring this for the first time. What I'm going to do here is I'm going to change the value of the maximum receive buffer size from 333 kilobytes to 577 kilobytes. All I did was make that change in the GUI. Right? I didn't do anything else or anything fancy. And I click OK. And now you look at the screen and it shows TCP protocol settings are updated in the change set. So this has been updated. You can also click on it and look again, and you can see here, it's hard to see on the screen, but they're easy to see on the panel. There's a green delta flag that tells you this is what's been changed in this change set. So you know what's been changed on this panel. Now, you can also compare the old and new values using View Details. So here I am in the change set editor looking at stack 1, and I click View Details. And View Details will show me what's different. You get this View Details report, and you see the View Details report shows you the stack configuration with a delta flag saying this is what's changed. You click on that, and it takes you to that section, and it shows you a table showing this is the value in the change set, and if it's been changed, this was the old value in the base. So in this example, like I said, the receive buffer size has been changed from 333 to 577. Saying the value here is 577, it was 333. These View Details tables are very sophisticated to help you see the changes. On the next slide, this is a simple one. This is a scalar parameter that has a value. Table parameters are a little bit more difficult. In this example here, I've changed the static routes. I didn't show you the steps for it, but the static routes were changed. So the next hop of the default route was changed. If you look at the default route, you can see here, here's the change set value. The base value of different, well, it's the next hop that's changed, right? And also, this new route was added. It also shows you what routes were deleted. So View Details helps you see what's before and after very clearly. So how do I install a change set? That basically means creating the obey file. So I've created the changes. You notice I have install status here of never installed. I click on Actions. The Actions menu pops up. I click on Manage Change Set Installs. And that takes me to an install screen. And it shows me that stack 1 is ready to be installed. And I can either show configuration file, which will show the contents of the obey file, or I can do install, which will push the obey file to the MVS system. Once the obey file has been installed, the operator just runs the variobey console command to put it into effect. So you can also undo a change set. That's an install action. So here I am back at stack 1. I'm on the install screen. It says that stack 1 has been installed now. The status is installed. I can right click on it and do install change set undo. And what that will do is that'll create a new obey file to put the parameters back the way they were before you installed the change set. So this is useful for fixing errors or for removing changes meant to be temporary. So after a change set has been installed, you can undo it. The change set, the thing about this, the reason we made this an install action is the changes are still there in the change set. So you can edit them or you can reinstall them. So it's an install action. You can install it, you can uninstall it. When you uninstall it, you still have the changes available in the change set editor, so you can reinstall it later, or you can make a slight change and install it again. The next thing you can do with the change set is merging it. You want to merge a change set in cases where it's a change meant to be permanent. So that makes it available for the next IPL, like adding a port for a new application. So after a change set has been installed, you can merge the changes by pulling down Actions, Merge Change Set into Base. So here I'm in the Change Sets tab. I've got my change set. I do Actions, Merge Change Set into Base. When I do that, this updates the base configuration to be the same as the change configuration, and then removes the stack from the change set because it's now the base. If this was the only stack in a change set, we just delete the change set because it's been merged. It's no longer needed. Now, when you merge a change set into the base, that does change the base configuration. So the base configuration needs to be reinstalled, right? Because you had a base configuration that had the old configuration. You merged it into the new configuration. Now the base configuration has changed. So the stack gets a status of needs install because the change set was merged. That way, next time you IPL the stack, you have the change permanently in. Now, because the stack needs to be installed, you can't do a new change set until this is installed. Because remember, you can only put a change set on installed configuration. So there are some restrictions on change sets. And you'll see this slide 3 times, one for each type, because I need to emphasize it. So when Configuration Assistant is creating an obey file for a change set, it creates the obey file necessary to change the base configuration to match the change set configuration. For this reason, Configuration Assistant must know exactly what's in the base TCP/IP configuration on the MVS image to correctly generate this file. So that results in 2 restrictions. The first restriction is, as I said before, a change set can only be based on installed configuration. For a stack change set, that means stacks whose status is needs install or never installed are not eligible to have change sets based on them. You have to install the stack profile before you can change it. Also, configuration with a change set based on it can't be edited. So a stack with a change set based on it, you can't change that stack in the GUI. You have to either delete or merge the change set before you can edit the stack, because we have to freeze the stack configuration so we know what we're making the delta to when we create these obey files. Alright, there's a special case for change sets that's kind of annoying but worth knowing. This is a COM server restriction, not a Configuration Assistant restriction. When you change an IP interface, you have to delete the old interface and add it as new. If you change the name, IP address, or most characteristics, the procedure is you have to stop the interface to be changed, form a variable obey to delete the interface to be changed, and then form another variable obey to add the new one. And COM server has a restriction. These have to be different obey files. You can't do the delete and the add in the same obey file. So because of this requirement, Configuration Assistant has special processing for these types of interface changes. We create 2 obey files. If you change an interface, we'll create a delete file, delete the old definition, and then another one to add it back. So in this case here, I'm going to do an example where I'm going to change interface OSA 2 to OSA 2A. So I'm in my change set editor. You can see here it says configure change set. I'm in the stack. I'm editing the interfaces. I select OSA 2. I pull down Actions Modify, and I type in the new name OSA 2A, and I click OK. And now when I go to install it, there are 2 configuration files. There's a configuration file and there's a configuration file for the delete. If you look at the configuration file for the delete, it simply deletes the old definition. If you look at the configuration file, it simply adds the new definition. So if you want to look at the new definition, here it is. So you have 2 files to do. You have to do the delete file first, then you have to do the new definition. These are created together, and when you do the install, so here I'm on this interface, I'm going to pull down Actions Install. You see there's 2 files you're going to install. You have to have the name for the delete file and the name for the install file. You can always change these names. We always provide a default, but you can always change them. So that also means when you undo this change set, right, you're changing the name back, the undo also creates a delete file and an add file. Like I said, these are the things we had to do to get to work with the COM server restriction on changing interfaces. Now there are other change set restrictions for IP interfaces as well. Because an IP interface has to be deleted to change it, you cannot change an interface that's referenced elsewhere, unless you also delete that reference. This is the same restriction you would have if you change the name of an interface in base configuration. So examples of where IP interfaces are referenced, like you can't change an interface that's a source VIPA, a static route outgoing interface, a primary interface for a stack, or a VIPA route target, unless you delete that reference in the change set as well. If you attempt to change an interface that's referenced elsewhere, you get this error message in the change set, which tells you where it's being referenced. Here we're saying the interface you're trying to modify is referenced as a routing interface. You cannot modify an interface that is being referenced. So you'd have to go and delete the static route. Probably what you would need to do is you would go in the change set, you would delete the static route, you would delete the interface, and then you would do another change set to add back with the new, and then you would add it with the new name. Hopefully changing interfaces like this is not a really common use case. We don't think it really is. We think mostly it's changing parameters and adding ports and things like that. So I spent most of the time on stacks to get the basics. Now we'll touch on how different types of change sets work differently. Here's an example of a change set based on a reusable configuration. In the Configuration Assistant, I have a reusable configuration that's installed into 2 stacks. Right? So this RC is installed into 2 stacks. I want to create a change set for that reusable configuration. We copy the existing reusable configuration into the change set, and then you make your user changes. You edit to make the changes, and then when you install, Configuration Assistant creates obey files for the stacks that use the reusable configuration, right? Because in the end, I'm changing the stacks. So we generate the necessary obey files to put the changes into effect on all stacks affected by the change, and we also install them into the stacks. And then your operator executes the obey commands necessary to put them into effect. So I'll step through real quickly, creating a reusable configuration change set. I'm creating a change set called tuning RC, and it's based on a reusable configuration. When I click next, it shows me the reusable configurations that I can base this on. The same rule about the configuration has to be installed applies here as it applies for the stack. I can only create a change set based on a reusable configuration that's been installed into the stacks and all those stacks are installed. For example, I can't create a reusable configuration based on OSAs or ports because they are being used by stacks that are not installed. You'd have to install the stacks to create a reusable configuration based on them. But tuning, I can create a reusable configuration based on that. So here's an example where I'm going to make a change. I'm going to change the maximum number of backlog entries. I've already made the changing them back here. So you configure it to the same way you would configure it in a reusable configuration. You simply make the changes you want as if you were editing it normally. In this case, we've updated the backlog limit to 2244 from whatever it was before in this reusable configuration. So with the reusable configuration change sets, there's an extra step. It has to be validated against the base because just like when you do a reusable configuration, you shouldn't be allowed to create configuration that can cause conflicts. For example, if in a change set you do something that causes a duplicate name or something to happen. So after you edit a reusable configuration change set, you need to validate it against the base, which you do that by simply either pulling down actions validated against base or right-click on the change set and do validate against base. And that will verify that your changes aren't going to cause any conflicts or errors with the base. When you install a reusable configuration change set, after you validated it, on this screen you can see the validation pass is checked, is correct. When you install it, we automatically generate obey files for every stack that uses the reusable configuration. You can then view, install, and undo the changes on a stack-by-stack basis. So for example here, I'll pull down Actions, Manage Change Set Installs. I get the install screen, and you see here in the install screen that there are 2 stacks because this reusable configuration is used by 2 stacks. I can go to each individual stack and click on Install. And I can also click on Undo if it's been installed, and I can view the configuration. The next step after you've installed it, if this is meant to be a permanent change, for example, you're adding a port for a new application, you wanted to get it in right away, but now you want it to be available for your next IPL, you can, just like with stacks, you can merge a reusable configuration change set into the base. When you merge a reusable configuration change set into its base, the reusable configuration is updated to match the change set configuration, and the changes are pushed to each stack that uses the reusable configuration, and the change set is deleted, because you can only have one reusable configuration per change set. Each stack that uses the reusable configuration must then be reinstalled to make the change configuration available for the next stack IPL. You see here in this example, the 2 stacks that use that reusable configuration now have a status of needs install, change set installed. And like before, you can't base a change set on something that hasn't been installed, so those stacks have to be installed before you can make any more change set activities. Now this is similar to the screen I showed you for stacks, but it's important to emphasize there are restrictions for reusable configuration change sets because of the fact that we have to know what's on your MVS system because that's what we're generating variable obey file differences for. So once again, a change set can only be based on install configuration. For a reusable configuration, that means the reusable configuration must be installed in all the stacks that use it, and those stacks all have to have an install status of installed. If you don't meet both those requirements, you can't base a change set on that reusable configuration. Also, configuration with a change set based on it cannot be edited. So for a reusable configuration change set, that means that a reusable configuration with a change set based on it cannot be edited in the Configuration Assistant. It also means that none of the stacks that use the reusable configuration that has a change set based on it can be edited. So it locks down the RC and all the stacks that use it. And these restrictions are in place until a change set is merged or deleted. And this is because we don't want you to be able to edit a stack in a way that would create a conflict with the reusable configuration that you're currently doing a change on. Okay, the third type of change set is a change set based on a Sysplex, which is the third major type of configuration. And this slide shows you conceptually how that works. So in this example here, I have an existing configuration. I have a Sysplex, which has 3 stacks in it. So Sysplex configuration is in each stack after being configured at the Sysplex level. If you create a change set based on the Sysplex configuration is copied into the change set, and then you make your user changes just simply by editing the Sysplex information in the Configuration Assistant. And once you install it, the Configuration Assistant generates the obey files necessary to put the changes into effect on all stacks affected by the change. And it pushes them to all of the systems that are affected by the change. I said all stacks affected by the change, not all stacks in the Sysplex, because not all Sysplex changes affect all stacks. For example, if you have a dynamic VIPA that's only backed up or defined on 2 of the 3 stacks, and you change that dynamic VIPA in the change set, you'd only get obey files for the stacks that are actually changed. So it's smart enough to know what stacks are changed and to generate the necessary obey files. And then once those files are out there, you can review them and your operator can execute the variobey command. So I'll show a few quick examples of creating a Sysplex change set. This is similar to the other types. You get the create change set screen, you name the change set, you make a comment, you indicate it's a Sysplex change set, and next you pick which Sysplexes this change set is based on. In this case, you can base it on Plex 1, but you can't base it on Plex 2 because you can see here that in Plex 2, one of the stacks needs to be installed. A change set can only be based on a Sysplex if every stack in the Sysplex has an install status of installed. This is the same restrictions before, that change sets can only be based on install configuration. In this example here, I made a change in this change set editor. You can see up at the top from the breadcrumbs, we're in the configure change set for Sysplex network resources. And I'm changing the workload manager polling interval. And it's been changed to 120 seconds from whatever it was before. You can see that there's a delta there telling you that it's been changed. So after we change the workload polling interval, then we want to install this change to the Sysplex. And here in the change set editor, I have the change set. When I install it, I pull down Actions. I click on Manage Change Set Installs, and you can see I get every stack in the Sysplex has an install file. So I need to go through these and install it. And just like the other types, I can, on a stack-by-stack basis, I can install, which puts the variobey file out there to make this change. I can undo, which puts out a variobey file that undoes the change, puts the value back to the old value. And I can view them on a stack-by-stack basis. A Sysplex change set merges just like other change set types. When I merge a Sysplex change set into the Sysplex is updated to match the change set configuration. The changes are pushed to each affected stack in the Sysplex, and the Sysplex is removed from the change set. If it was the only Sysplex in the change set is deleted. Each affected stack must be reinstalled to make the change configuration available for the next stack IPL, or if you want to put a new change set on that stack. Now, change sets have restrictions just like everything else, because we got to go back to our 2 main restrictions, which is that a change set can only be based on install configuration. For Sysplex, that means every stack in the Sysplex must have an install status of installed for the Sysplex to be eligible to have a change set based on it. Also, configuration with a change set based on it cannot be edited to make sure they stay in sync. For a Sysplex change set, this means that the Sysplex cannot be edited, and none of the stacks in the Sysplex can be edited either. So when you put a change set on a Sysplex, you lock down the Sysplex and the stacks in that Sysplex. And just like the other ones, these restrictions are in place until a change set is merged or deleted. Alright, thank you for your time. Hope you found this presentation useful. My email address is on the first slide for feedback and questions. Thank you.